We're going to look at 4 research project case studies today, and the first of the 4 is one that's being funded by one of our superstar best-in-class utilities, UOSA. And Bill, you've worked really closely with them on this. Can you tell us what UOSA is investigating with this project regarding pairing ozone and biofiltration with granular activated carbon for better results?
Sure. We're piloting ozone addition upstream of GAC biofilters to see if that technology can more effectively remove organics and make the GAC last longer. We're now in the 2nd year of pilot testing, and the data is pretty amazing. Fantastic results for COD, TOC, UV254, trace organics, DBPs, etc. Letting bacteria do the work instead of simply using GAC for absorption is cost-effective, sustainable, and has a lower carbon footprint. The biofilter GAC media lasts longer and saves money. Okay, this slide shows testing for the removal of trace organics, such as pharmaceuticals and pesticides, at the UOSA pilot plant. The test was in the 3rd month of pilot testing to allow several months for biofilter acclimation. 60 to 100 analytes were evaluated. And you can see on the upper right of the slide, about 30 trace organics were detected in the treated wastewater prior to the ozone biofiltration step, such as low concentrations of pharmaceuticals. The highest spike there is sulfamethoxazole, that's an antibiotic, and the 4 out of the 5 highest spikes were pharmaceuticals. The 5th was DEET, which is insect repellent. The uppermost slide to the left then shows how there's some removal, but still a fair amount of the trace organics after biofiltration with spent GAC. Spent GAC is GAC that's over a year old, so the absorptive capacity is spent. If we just add about 2.5 milligram per liter of ozone, as shown on the chart that's on the lower left, then you can see that most all of the trace organics are removed because the ozone makes the organics more biodegradable, and then the bacteria do the work for you. Similarly, GAC that's freshly regenerated will remove the trace organics, as shown in the middle chart on the right. And the combination of regenerated GAC with ozone does the best, as you'd expect, as shown in the chart on the lower right. But regenerating GAC is much more costly than 2.5 parts of ozone. So that's why we're looking at the cost effectiveness of the ozone biofiltration. And all the organics tested here, all the organics we've tested are below drinking water limits. Project testing is wrapping up in a couple of months, and we'll be publishing a report at that time. And Bob Angelotti and I will be presenting this information at the AWWA and WEF national conferences.
All right, so if you want to know more about this, folks, you can obviously reach out to Bill, or you can just join us in Philadelphia or Chicago to see those presentations. That's an awesome project. Thanks for sharing that with us, Bill.